Hello everybody. In this week we will discuss about chapter 2 of the course of electrical and electronic equipment for industrial machinery. In this chapter we will discuss about the basic AC theory, complex number, analysis of AC circuits, resonance circuits, and power factor. The learning outcome is LO 1.1. Understand the concept, term, quantity relating to electric circuits. And LO 2.2 explain working principle and analyze basic quantity of AC electric circuits. Now we will discuss about the basic AC theorem. AC or alternating currents is an electric current in which the flow of electric charge periodically reverse direction. And AC is the form in which the electric power is delivered to the business, to the residents. The usual waveform of AC is mode of electric power circuits is the sine wave. And why the waveform of AC is the sine wave? I will explain why. To generate the alternating current, we use the AC generator. In the AC generator, we put a coil into the magnetic field, and the coil rotates from angle 0 to 360 degrees. AC voltage is generated as shown in above figure. For the half turns from 0 to 190 degrees, the positive half circle is generated. The load current flow in the forward direction, and for remaining half turn from 190 to the 360 degrees, the negative half circle is generated as shown in the figure. Due to the negative voltage, now load current flow in the reverse direction, and the circuit repeats periodically as the generator the rotating mechanism. That's reason why the waveform of AC is the sine wave. The advantage of AC over DC. AC is less expensive and easy to generate than DC. AC can easily convert into DC using the rectifier circuits. The variation of AC can easily be done by using the transformer either set up or set down. The power loss during transmission in AC is less when compared to DC. Now we will discuss about the basic quantity of AC. Remember, AC waveform is the sine wave, and this is the formula of the current and voltage of AC. Because the AC waveform is the sine wave, they have the periods, frequency, the phase, and the amplitude. First one, the periods. Periods is the time it takes for one complete circle of an AC signal. Periods is measured in the second. And the frequency is the number of circles in a single second. Frequency is measured in the hertz. Next, we will discuss about the phase of the AC signal. The phase shift. The phase shift is where two or more waveforms are out of step with each other. And a leading waveform is defined as the one waveform that ahead another in its evolution. You can see in this case the current is the leading waveform, and the lagging waveform is one that is behind another. And you can see in the figure the current is the lagging waveform. Now we will talk about the amplitudes of AC waveform. We have the four kinds of amplitudes. The peak amplitude is the height of AC waveform and measured from the zero mark to the highest positive or lowest negative point of the graph. And the peak-to-peak amplitude is the total height of AC waveform and measured from the maximum positive to the maximum negative pitch of the graph. And the average amplitude for the sine wave, the average value can be calculated the approximate of the pitch value. Is the pitch value multiplied the 0.637, and finally the root mean square value RMS for the sine wave. The RMS value is approximate of 0.707 of the pitch value. Calculation for AC circuit must take into consider both amplitude and phase shift of voltage and current waveform to be completely accurate. And for conventional to analyze the AC circuits, we can use the complex number to show the AC signal. AC quantity in single-phase circuits have both magnitude and phase. A complex number is mathematical quantity representing two dimensions of the magnitude and direction, and we can use the vector to show the complex number. And when used to describe an AC signal, the length of the vector can show the amplitude of wave, and the angle of the vector can show the phase angle of the wave relating to another waveform. A complex number can show in the polar notation or rectangular notation. For the polar notation, it denotes the complex number in the term of its vector length and angular direction from the starting point. You can see in this figure, we have the vector with the length is 5 and the angle is 36.87 degrees. Also, the complex number can show in the rectangular notation. It denotes the complex number in the term of its horizontal and vertical dimension. You can see the vector in this figure. It shows the 4 plus j3. 4 is the real part and 3 is imaginary part. Now let's see the example with AC circuits. Calculate the total voltage of this circuit. E total equals E1 plus E2 plus E3. And you can see E1, E2 and E3 show in the polar notation. You can convert it to rectangular notation and sum of them, and you have the total voltage. Now let's analyze some AC circuits. First, we consider the AC resistor circuits. This circuit only have one voltage source and one resistor, and the current through the resistor can calculate by using the Ohm's law. I equals E divided R sine omega t. And for AC resistor circuits, the voltage and the current in phase, and the power is always positive. It means the resistor absorbs the energy from the source and release the heat energy into the environment. Next, we will consider the AC inductor circuits. This circuit only have the one voltage source and one inductor. The current through the inductor can calculate by using the Ohm's law. I equals E divided omega L sine omega t minus pi over 2. And in the AC inductor circuits, the power may be the positive or negative. The positive power is mean the inductor is absorbing power from the circuit, and the negative power is mean the inductor is release the power back to the circuit. For AC inductor circuit, the voltage lead current 80 degrees in phase. Now I will introduce the new terminology, reactance. Reactance is the opposition that inductor or capacitor offer to AC due to its phase shifting storage and release of energy in its magnetic or electric fields. Reactance is symbolized by capital letter S and is measured in ohm, just like a resistance. Reactance of inductor can be calculated by using this formula. SL equals 2 pi FL. Reactance is similar to resistance, but the difference in field weight. Reactance changes the phase. The power is not released into the environment in the purely reactive element, but is stored instead. Reactance depending on the frequency of the AC circuits. You can see the reactance of 10 mH inductor in this table, and reactance is spread by imaginary number. Now let's see the AC capacitor circuit. This circuit includes a voltage source and capacitor, and the current through the capacitor can be calculated at this equation. With S is the capacitive reactance. S equals 1 divided C omega or 1 divided 2 pi Fc. And you can see the reactance of 100 microfarad capacitor in this table. For AC capacitor circuit, the voltage lag current by 90 degrees in phase. Now let's analyze the circuit with inductor and resistor. The resistance of this circuit is 5 ohm. It means R equals 5 plus J0. And the reactance of inductor is the 3.77. It means it's equals 0 plus J 3.77. Now I will show the new terminology. Impedance. It is the total measure of opposition of electric current, and it is a complex sum of resistance and reactance. It is symbolized by letter G and measured by ohm, just like the resistance and reactance. And total impedance equals G equals R plus X is equal 5 plus J 3.77. And we can calculate the current through the circuit by using the Ohm law. I equals E divided Z is equal 1.7. Now we will discuss about resonance circuits. As you know, the capacitor store energy in the form of electric fields, store energy as the potential, static voltage. And inductor store energy in the magnetic fields, store energy as the kinetic motion of electron, is current. A capacitor and inductor directly connect together form something called as the tank circuit. If either the capacitor or inductor start out in the change state, the two components will exchange energy between them, back and forth, creating our AC voltage and current circuit. A tank circuit includes the capacitor and inductor oscillate at a particular frequency. It's called as the resonance frequency. F resonance equals 1 divided 2 pi square root of LC. At that frequency, energy alternately shuffles between the capacitor and inductor in the form of AC voltage and current 90 degrees out of phase with each other. When the power supply frequency of AC circuit exactly matches that circuit natural oscillation frequency as set by L and C component, a condition of the resonance will have been reached. That is resonance phenomenon. Usually, we avoid the resonance phenomenon, but in AC circuit, we can use the resonance for some application. The resonance can be used to maintain AC circuit oscillation at a constant frequency, just like a pendulum can use to maintain a constant oscillation speed in the timekeeping mechanism. The second, the resonance can employ for its impedance property, either dramatically increase or decreasing impedance for a certain frequency. It's called a filter. Now we will go to the last part, power factor. In the AC circuit, we have three types of power. The first one is true power. The power dissipated by a load is referred to as the true power. It's a function of resistance, R, and it has this formula. And the second one is reactive power. The power absorbed and returned in the load due to its reactive property is referred as the reactive power. It's a function of X reactance, and it has this function. And the last one is apparent power. It is the total power of AC circuits, both dissipate and absorbed return. It's the function of impedance, and we have this formula. Finally, we have the terminology power factor. The power factor is the ratio between the true power and the apparent power. The power factor can calculate by using the P divided S. The larger power factor up to 1, the greater the active power. The power factor characterizes the ability of electric equipment to make use of their energy of the source to be useful. That's all for this week.